Hi guys, so I think we did this question in class, but I wanted to go over it because it is a bit of a tricky question. So let's go ahead and get started. Alright, so this question says, viewed from Earth, the North Star and Betelgeuse are separated by an angle of about 83 degrees. If the North Star is about 430 light years from Earth and Betelgeuse is about 640 light years from Earth, then about how far in light years are the North Star and Betelgeuse? So ultimately, we want to find this distance right here. We know that this is 430 right here and this is 640, so you might think, okay, I could just do the Pythagorean theorem and be done, right? But the thing is that this is not a 90-degree angle, so I cannot do that. But I can create auxiliary lines, so I can create an auxiliary line here, make this a 90-degree angle, and this is my angle that they give me. I know that the opposite would be this one. My right angle is right here in this corner, so the opposite of that is over here, so that means that that's my hypotenuse. And then by the way, to figure out the hypotenuse, you already know that it's the longest side, but it's also across from the little square, showing that it's a 90-degree angle. So yeah. And then lastly, this would be my A. Whoops, what happened? Okay, this would be my A right here. So I could do the Pythagorean theorem if I know that this whole thing right here is 430, right? And that was very ugly, but let me use my pointer instead. I know that this whole thing is 430, and I don't know what this is. So if I can just take this and this right here, if I know the distance from here to here and from here to here, then I can use the Pythagorean theorem. So I need to know what A is. So we're going to solve for A. So if I do A is, so we have SOHCAHTOA. So they give me H and I want to find A, so that means that I'm going to use cosine. So I have cosine of 83 is equal to A over H, which is 640. And all we're doing is solving for A, so multiply by 640 on both sides. And I get that 640 cosine 83 is equal to A. So that means that A is equal to 77.99 whenever you type this in the calculator. So this right here is 77.99. So now I wonder if I have more colors. No, I don't have any more colors. Okay. So that means that I have A and I have the hypotenuse here. So I can find O now. I can do, because remember, this itself is a right triangle. So I can do the Pythagorean theorem with this small triangle, okay? So I can do 77, let me get my pen, 77, can y'all see that? I think I'm on the highlighter mode. 77.99 squared plus b squared is equal to c squared, which my c is in this case would be 640. And whenever you do that, you get 77.99 squared, that is 608.2.44 plus b squared is equal to 409,600. So then you subtract, we're solving for b. And then we get that b squared is equal to 403517.56. Then you take the square root of that, and you should get that b is 635.23. So I know that this right here is 635.25. Okay, so I know now, I know that this is 635.25. I can figure this out. I can figure out what this is, because if this whole thing is 430 and this little part is 77.99, all I do is I have to subtract them to get this right here, right? And then I can do the Pythagorean theorem for this. So let's go ahead and do that. So whenever I do, oh no, oh my god, this thing is so finicky. Okay, whenever I do 430, bro, where is my, okay, here we go. 430 minus 77.99, I get, let me use a calculator for this. 430 minus 77.99, I get 352.01. So this right here is 352.01. So now that's a right triangle. I can actually use a Pythagorean theorem now. I can do 352.01 squared plus 635.25 squared is equal to c squared, and solve for c. And I'm gonna let you guys do that, okay? Because I don't want to make this video too long. But I'm gonna tell you what the answer is. C is gonna be equal to 726.24. So that would be, and this is light years, right? So light years. LY for light years. So this would be 726.24. Now in class, we drew two auxiliary lines. We drew this one, and we also drew one that was going from here to here. So you could do the same thing for the one that goes from here to here, from the North Star to this line right here, right? Same thing applies. But I'm not gonna do it because for the sake of time, I don't want to make this video too long. But you could do it both ways, okay? So there's two ways that you could do this. If you want to use the horizontal line that the horizontal auxiliary line that we drew, you can do that. Or if you want to use the vertical auxiliary line, you can do that as well. It's the same concept. You would still use cosine, but instead of 640, you will be using 430, right? So yeah, moving on. Let's see. Okay, so use the triangle below to determine the values indicated. So sine y. Sine, you should already know the acronym here. Or if you don't have to remember the acronym, but just know a way of, if you understand this. So SOHCAHTOA. So they want us to find sine y. So this is y. That means that my opposite is going to be right here, because that's the one across. My hypotenuse is the longest leg, but also another way to figure it out is you look across from that square, and that would be my hypotenuse. So that leaves that this is my opposite. So for sine, I have sine y is going to be the ratio of opposite over hypotenuse. The opposite here, oh wait, why did I draw an A? Why did I didn't do my A? I meant to put A right here. Sorry guys. A right here. So I know that my sine is opposite over hypotenuse. The opposite here is 20, and the hypotenuse is 29. And this would be my answer. That's all they want you to know. They just want you to know the proportion. You could, divide it and get the decimal, but if you did that, that's fine. But, they're talking about the ratios, and a ratio is a fraction. So ideally, you would leave it as a fraction, but it's the same thing. Okay, moving on. In this diagram, triangle ABC is similar. So this little symbol right here, means similar. So triangle ABC is similar to triangle WYZ. Okay. So determine the missing side lengths in both triangles. So we know that this is 130, this is 194, and we know that this is 1, but we don't know what this is, we don't know what this is, and we don't know what this is, right? So I can set up a proportion here. So I know that, well, actually, no, not even. Before I do that, I can just do the Pythagorean theorem for this. This is a right angle, so I know that this is either my A or my B. I know that this is my C, and I can figure out what this is. So if I do 130 squared plus B squared is equal to 194 squared. Let me pull up my calculator real quick. Okay, so 130 squared is 16900 plus b squared is equal to 194 squared is 37636, and we're solving for b, so subtract that, and then we get that b squared is equal to let's see, 37,636 minus, I get 2736, and take the square root of that. 2736. I get that b is equal to 144. So this right here is equal to 144. So now I can set up a proportion, because similar triangles have the same, they obviously have the same angles inside, but also even though they have different sizes of lengths, they are proportional to each other. Like the ratios are proportional. So if I know that this is 130 and this is 144, and I know that this is 1, but I'm trying to find this one, I can simply set up a proportion like this. So I can say 130 over 144, right, is equal to, with the 144 goes with the 1, so these two are together, so that has to go in the bottom, and I'm trying to find what this is. So I'm going to do 130 times 1, which is just 130, and then 130 divided by 144. Okay, and that will give you my x. So whenever I do 130 divided by 144, I get 0.902, but I'm gonna leave this as a fraction. Because these are, these are ratios, these are proportions, so we're gonna leave this as a fraction. And also for this question right here, since it's in a fraction, I want to be able to easily find the answer, so it's gonna be left as a fraction. So this is 130. What do we do? 130 divided by 144. So 130 divided by 144, we have to reduce that. What number divides both 130 and 144? I think, is it 2 or 4? Let's try 2. So 130 divided by 2 gives me 65. And then 144 divided by 2 gives me 72. And then I don't think I can simplify that anymore. 65 divided by 5. Yeah, because the fact, to get 65, I would have to multiply 13 times 5. And to get 72, that's 9 times 7. Or not 9 times 7, oh my god, 9 times 8. Which I cannot divide by any of those. So this right here is 65 over 72. Okay, and you kind of want to leave this as a fraction, because if you look at part B and part C, they're in fractions, so it's just going to make our life easier. But if you reduce it to a decimal, that's fine. So now we have to find the other missing length, which is this one. And you could do the Pythagorean theorem, but there is an easier way. We can just continue using proportions. So that's what I'm going to be doing. So I can use any proportion, it doesn't matter, but I kind of want to stay away from that fraction. So I'm going to be using, let's see, I can use 194 over 144. So I can use this and this, because I'm missing this one and I know what this is, right? Because I don't want to deal with this fraction. So that's just what I'm going to do. If you want to deal with it, that's fine. You'll still get the same answer as me. Okay, so let's see. If I have 194 over 144, and I don't know what this one is. This is the corresponding sides. I don't know what that is, but I know that this is 1. So then all I have to do is multiply 194 times 1, which is 194, over 144. So really it's the same thing, right? But I want to reduce this to its simplest terms. So 194 divided by 144, well, let's keep it as a fraction. So let's go ahead and see what number we can divide this by. Or we want to reduce the fraction, right? Did I say that already? Oh my god. Sorry guys, it's like 5 in the morning, so I'm still waking up. So 194 divided by 2. So that would 2 times 97. And 97, that's it. You can't factor that anymore. And then we're going to do 144 divided by 2. And that's 72 times 2. So these reduce, and I'm left with 97 over 72. So this right here is 97 over 72. So 90. Whoops, what is that? Oh my god. Hello? Bro. I just want to make this video. Okay. Let's see. What did I do to this thing? Oh my god. Okay, guys. I don't know if y'all can see what I'm seeing, but we're gonna ignore it because I don't know how to get rid of it. Okay. Oh, there it goes. Okay. That was weird. Okay, so 72 right here. So this right here is 97 over 72. Let me make that more neat. So, oh, that's what it did. Now I can't erase anything. So this is 97 over 72. Okay. So I found all the missing links. All right. So now let's do part B. And part B, let's see, what do they want? Which angles have a tangent of 72 over 65? So we know that tangent is opposite over adjacent. So I'm going to write that down right here on the side. Tangent is opposite over adjacent. And they want to know which one is 72 over 65. So if I do, how did I get 65 over 72? I got 65 over 72 by doing 130 and 144, right? So that means that if my A was my angle, then that would be, this would be my opposite, this would be my adjacent, and this would be my hypotenuse. So let's see if that works. So tangent O is 144 over 130. And that we have already established that reduces to, right here we got 65 over 72, but since my numbers are switched, this is also going to switch, which is 72 over 65, which is what they want. So which angles have that? It would be angle A. So how do I write that? Let's see. So it would be tan of A. And since these are similar, that means that this would also be, since we use this one and this one, that would be the same thing as using this one and this one. So this angle corresponds to this angle. So A is the same thing as W. So tan A and tan W. Okay, so that's my answer to that. All right, moving on. Which angles have cosine of 90, 99, 97 over 65? Did we have a 97 here? Yeah, I think we did. Let me see. 97 over 65. So right here I had, let me use my pointer. 90s, I see a 97 right here. And I got this 97 from doing what? 194. From 194 over 144. 194 over 144. But that gives me 97 over 72. And I want 97 over 65. There is no angle that's going to give me that. Like, you can try it if you want to see. I'm not going to show you, but I'm just going to tell you that there's no angle that's going to give me that. Okay, so this one would just be none. So none for this one. And we're done with this section. So none. Okay, number 3. So consider the right triangle ABC, which is the following expressions is equivalent to angle. The measurement of, sorry, not angle, the measurement of line segment AB the length of the hypotenuse. Explain your answer. So 12 sine A. We need to know what the hypotenuse is here. So 5 squared, I do Pythagorean theorem, 12 squared is equal to c squared. That's 25 plus 144 is equal to c squared. And then that's going to give me 169, c squared. Take the square root of that, so I get that c is equal to 13. So this is 13 right here. And the first question says that we want to find which angle measure of AB is equivalent, like which angle is equivalent to the angle measured of AB, which is the hypotenuse. So which one of these is going to give us 13? So if I do 12 sine of A, well, I know that SOHCAHTOA, oops, let me go back. I know that sine A is basically just opposite over hypotenuse, and this is a hypotenuse. If I'm doing angle A, that would mean that my opposite is this one, and this is my adjacent. So basically, I'm gonna have to erase this. So I'm gonna have 12, and then sine A, I'm gonna replace that with 12 over 13, because remember, so like O over H, which would be 12 over 13. That's how I'm getting that. And then whenever I reduce that, did I do that right? Wait, hold on. O over H, 12 sine over H. Let me check something real quick. Yeah, whenever I do that, I get 12 times 12 is 24, and then 24 divided by 13. That does not give me that is equal to 13. Remember that I want to see which angle measure is equal to 13, because that's my hypotenuse. So that does not give me 13. That would be 24 over 13, which we cannot reduce that. So then, let's see. If I do, I'm only going to do 2 of these, okay? So if I do the B, so that's 12 over cosine of A. Well, that's the same thing as 12 over cosine of A. Cosine is A over H, so that would be 5 over 13. And remember, I need to get rid of this fraction, so if I put this over 1 to reduce it, I get 1 over 13, 1 over 13 here. These cancel, and I'm left with 12 over 5 times 13, that's 45. And 12 over 45 is not equal to 13. So once again, this does not work. So, yeah, that does not work. So, I don't know, try C, D, E, and F and see if any of those, whenever you simplify it, give you 13, and that's going to be your answer. Okay, moving on. So, oh my god, this video is already 23 minutes long. I'm going to try to make it 30 minutes long, okay, guys? So, let's hurry. On handout, you use the tangent ratio. You use the tangent ratio to solve the following problem. Now solve it using a different ratio. For driving safety, it is important for a driver to think about how far their car will travel by the time they finish with a maneuver. Suppose a car is moving forward in a straight path. To change lanes, the driver must turn the steering wheel slightly. This causes the car to travel in a direction that points 2.1 degrees away from the forward direction. Once the lane change is complete, the driver turns the steering wheel so that the car moves forward again. If a lane on the highway is 12 feet wide, how far forward will a car travel to change lanes? So you know that this is the length that they travel to change lanes, okay? And these are corresponding angles. So this is my right angle. That means that this is also my right angle. So I can do, if I know what this is, I know this is my angle, first of all. So I know that this is the opposite. This is my H, and this has to be my A. And I know that the vertical distance here is 12 feet. So I have my opposite, and I want to find what is H. What is that distance traveled whenever it changed lanes? So let's pull up our trig. SOHCAHTOA. And since I want to find H and I know what O is, we're going to be using sine. So I have sine of 2.1 is equal to 12 over H, and solve for H. So times H times H. And then we're going to do H times sine 21, or not 21, 2.1 is equal to 12. And then I have to isolate the H, so divide by sine 2.1, divide by sine 2.1. And then I get that H is equal to 12 over sine 2.1, which is equal to, oh my god, I didn't write it down. Let me calculate that real quick. 327.478 feet. Okay, so that's how you do that one. If you wanted to use the angle 87.9 right here, you could have also done that. That would mean that this is your opposite, this is your H, and this would be your adjacent. Okay, and you know that this is 12 feet. You know that this is 12 feet. So you could have done opposite over, yeah, same thing. It would have been sine. So you could have done that as well, okay? But yeah, that's the answer. All right, moving on. Okay, so it says, as two boats are coming to the end of a race, a top view of their position is shown in the diagram below. Both boats are approaching the finish line at an angle. At the moment shown, the left boat is a little closer to the finish line, 100 meters instead of 110 meters. On the other hand, the right boat has an advantage because it is moving more directly toward the finish line, 22 degrees instead of 20. All dashed lines in the diagram run directly north-south. Okay. If the boats follow the path shown at the same speed, which boat will cross the finish line first? All right, so let's see. So I know that this is 22 angles. So these are corresponding, these are alternate exterior angles. So that means that this is also 22 degrees. Same thing here. This is 20. So that would mean that this is also 20. Okay, and I have my right angle right here. Okay, so that means that this is my opposite, this is my hypotenuse, and this is my adjacent, and here my opposite would be here, hypotenuse and adjacent. Okay, so then we can go ahead and start solving for this. So I want to know what H is. I want to know how long it's going to take them to finish. They give me what O is, and I know what, hold on just a second. Sorry guys, I had to take that phone call. Okay, so what was I saying? I'm trying to find what H is, and I know what O is. So that means that if I pull up my SOHCAHTOA, whoops, I'm going to be using sine. So I'm going to have sine of 20 is equal to, oh my god, I'm running out of space. I'm going to have to erase this. Okay, let's change the color. So sine of 20 is equal to opposite, which is 100 over H. And I'm going to solve for H, so let's do that over here. So I have to multiply by H on both sides. And then I get H sine 20 is equal to 100. And then divide by sine 20. So I get H is equal to 100 sine 20. And I'll let you calculate that. And you're going to do the same thing for the second triangle, okay? So whichever one has a shorter distance is going to be your answer. All right, so if the speed of each boat is 10 miles per second, then how long will it take in seconds for the losing boat to cross the finish line after winning boat crosses the finish line? All right, so for this one, you have to set up a proportion. So you're going to have, I'm just going to tell you how to do it. You're going to have 100 meters per 1 second is equal to whatever number you got from doing this over x, and then you multiply across and you divide by 100. Okay, so that's how you're going to do that one. If that doesn't make sense, let me know and I can guide you better in person. Oh my god, no, it froze everything. Why is it doing that? Ay, ay, ay. Okay, almost done, guys. I'm sorry. When a half moon is in the sky, the position of the earth, moon, and sun form a right triangle. Over 2,000 years ago, the mathematician Aristarchus used this fact to estimate the earth to sun distance relative to the earth to moon distance. Below is a diagram of the earth to moon and the sun when there is a half moon visible in the sky, and the angle from the earth to sun is approximately 89.85 degrees. Use a triangle to estimate the earth to sun distance as a multiple, so key words here, as a multiple of the earth to moon. So from earth to sun is a multiple of the earth to moon. So we have to give these numbers. Let's say, for example, that this is 2. If it's a multiple, the earth to sun is a multiple of the earth to moon, that means that this would be 2 times x. Okay, and these are just numbers. You could have used 3, you could have used 4, you could have used 1. Okay, we're just assigning multiples here. So this is my angle. That means that this is my opposite, this is my hypotenuse, this is my adjacent. So then I'm trying to find the earth to moon and the earth to sun. So I'm trying to find A and H. So that means that I'm going to have, if I have SOHCAHTOA, I'm going to be using this one right here. So adjacent over hypotenuse. So the cosine of 89.95, or no, 89.85 is equal to 2 over 2x. And whenever I reduce that, I get 1 over x. And then I solve for x, so multiply by x, multiply by x. So then I get x cosine 89.85 is equal to 1. And then I have to solve for x, so then divide by cosine 89.85. And then I get that x is equal to 1 over cosine 89.85. And I'll let you compute that, and that's your answer, okay? All right, guys. I'm so sorry I didn't make this video until literally Monday at 5 in the morning. But, you know, life happens. So hopefully you guys are able to watch this video, and I hope you guys have a good start of your week. Goodbye.